Welcome back to the stream, anyone and everyone who's visiting. I'll start out with some cat, as per availability. Streaming a little later than usual here. It's like almost 9 o'clock, but you know, you stream when the stuff is ready for the streaming. So the cat's doing the cat thing, and I am in between two stages of this project, about to do some setup. Hey, Tuco. Oh, we're already getting a preview of the previous experiment here. Hey, cat. Do you want some bolts? So, let's see, this stream is going to mostly be about this contraption here. This is the Siemens Logo PLC, which has been in all sorts of states of teardown and sort of modification on the stream. But here is a pristine unit they were going to prepare for some voltage glitching after I bricked the first one. And over here, that is the first PLC, the one that's bricked, and I spent most of today getting this set up, kind of debugged to the point where it can run. Oh, geez. This camera arm is not happy. Hey, Tuco, you really want some bolts, don't you? I know that noise. You're so insistent. I think if I do this with the arm in this angle, this will spread ball bearings all over the floor. Hey, Tuco. All right, let's see if I can fix this arm without dropping everything. This thing's got to break about once every other stream. Not quite sure what to do about it. Like, I suspect the root cause of this is something getting worn down inside of this machined part that holds some bearings. And I mean, maybe I can get a replacement of just that part for this thing. Or maybe there's some other kind of maintenance I could be doing to it to prevent this. I think that was the fix. Hey, Tuco. I'm literally holding too many things to throw that for you right this moment, but I'll be with you in just a second. Hey, cat. Is this what you want? Yeah, he likes those things. But you want me to throw it farther than that, don't you? Hey, Tuco. Okay. Can this lock? Oh, it can. Great. Okay, anyway, so let's point this at the electronics, since that's kind of what this is supposed to be about. Okay. So here is my, you can tell it's the work laptop because of the logo. So this circuit board here is from the Siemens PLC. It's got a bunch of modifications that aren't especially relevant for this particular stage of the experiment. But in this particular brick state, the only interesting interface that it seems to be willing to communicate over is the SD card. So here I have an FPGA board. This is the Papilio Pro, and it's running this weird little system on chip that I've put together called FlipsyFat, which emulates an SD card and provides a bunch of programming interfaces for serving out blocks over that SD card and then doing triggering and time stamping and stuff like that that's useful for these sorts of experiments. And so that's running this experiment that you can kind of see going in the, just barely in that window maybe. Usually I would be screen capturing this, but I kind of don't want to mess with it enough to set up the HDMI output right now, so I'm just going to point the camera at the screen. Oh, and that's still crunchy. Hey, Teak, where's the bolt? So the gist of it is you can see it emulating an SD card in a way where it can return different data every time it's having its root directory scanned. And so by doing this, I'm running through this experiment that tries a lot of different file names. And you may have seen a previous stream where I was doing this kind of manually with like a hex editor. So in another version of this, I have a hex editor program that's just like got a live connection to the same memory that's being served out of this emulated SD card. So that was like a good first step. That helped me get a feel for which parts of the directory entry were meaningful. And I guess through that, it gave me some confidence that the order of operations looks something like, it's got a for loop that's scanning through all the directory entries in the root directory on the SD card. Then for each directory entry, first it checks to see if it's a volume entry so that it can ignore it. So we're getting past that check. I've also been using that check as a control in a lot of these experiments, since we know how that one works now. If the volume entry flag is set, then we can still see it visiting that directory entry, but it exits out even earlier than it normally would. So if it's not a if it's not a volume entry, then none of the other fields in the directory entry seem to affect it. So it doesn't seem to care whether it's a file or a directory. It doesn't seem to care about the size or the modification time or anything else. And I'm not getting any response from just changing single bytes of the file. So when I started this experiment, I was hoping that I could just go through like A, B, 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 etc. And I'd hit upon one of those that would show me a slightly longer execution time when it's processing the results of that directory entry block read. And I didn't see that, just changing things byte by byte, but everything else in the pattern fit into place. So I think the explanation that makes the most sense at this point is that it is just looking for a file name, but that it's not doing a string compare, it's doing a mem compare, and the mem compare happens to be aligned on either a 16 or 32-bit boundary, which means that the individual instruction that's doing the comparison isn't going to be looking at just one byte at a time, it's going to be looking at 16 or 32 bits at a time. So this experiment is designed to try to test that hypothesis, basically. So it's running through a lot of different file names, and well, we can take a look at the source code for this in a sec on the other computer so we don't disturb this while it's running. But it's basically got a main loop that's generating guesses, like basically a word list of file names to try. And that can be generated any way you want. That's like the meat of the experiment, the tofu of the experiment, whatever. But that main loop is just sitting there kind of coming up with guesses. And then I have this other machinery that runs as kind of a combination of a coroutine and some interrupt handlers, which ends up kind of pumping those file name guesses through this machine that uses individual blocks of the file name or the fat root directory to each test one guess. So when it serves out one of those blocks, it'll just pack that block entirely full of replicas of that guessed, and then it'll use accurate timers in the hardware to timestamp both when that when the last byte of that guess goes out, and then when the next command comes in. So then we can actually time like how many CPU cycles is the device under test spending thinking about that packet before we see the next communication from it. And the timing is all nice and synchronized since it's, I needed an external clock anyway since I'd ripped off the onboard oscillator from this thing. So I have the FPGA here generating its clock as well. Oh, that still feels terrible. Okay. Well, you can kind of see the, so these blinks should pretty much correspond with the lines of serial data coming out, because that's from the UART. There is another activity LED on here, which is not nearly as bright. You may be able to see it dimly turn on and off. And that one's actually driven by the FPGA to signal when it's waiting on the CPU to do something. And so if you look really closely on that, you may not be able to see them in the video, but it tells me when we're waiting on the PLC versus when we're waiting on the CPU. And then this set of cables is the emulated SD card signal. It was easier to use that than the giant ribbon that I'd been using previously and seemed to have better signal integrity. So this is just carrying the SD signals necessary for SPI mode, which is what this is using. Then over here, this is just some miscellaneous stuff that I had to solder directly onto the board that's broken out. So I've got that's how I'm bringing power in. There's power that normally is 8 volts or so coming from the bottom board in the stack up here. But it looks like I can get to the point where it's reading the SD card without any of the hardware on that bottom board, so I've omitted it from this experiment. And it also looks like without that other hardware, it's happy enough to run off of 5 volts. So I just have that 8 volt input that normally is connected to that second I/O board. I just have that connected to the 5 volt rail on this FPGA so it can all run off my laptop. And then there's reset in, so that this thing uses a GPIO on, so it's got like 16 bits of its I/O reserved as GPIO for the CPU to use as whatever, and in this experiment I'm using one of those to reset the CPU. And then I think one of the other pins here is clock. I think that's all that's going on. I tried to simplify this as much as possible. So that's going on. It's going to take probably, into tomorrow to finish this, but it's way faster than I initially thought this experiment was going to be, since I made some changes to optimize it for higher speed. I played with the clock rate, just tried to run it as fast as I can without hitting limitations of the janky setup here. And then, but like not over the speed it normally runs at, because I don't want to break it even further. And then, what else? Oh yeah, the big change. Well, so when I was doing this on the oscilloscope, I was doing one experiment per, how long it takes me to change the directory entry and then evaluate on the oscilloscope whether something changed or not, using the averaging and persistence and all that. With this really accurate clock combined with the timestamp registers to let me automate more of this in code, now I just have some code that's recording like, okay, this is how many clock cycles it spent. And it doesn't vary much at all. It stays constant within approximately the width of my clock divider, so it's basically the phase noise in when those two clocks choose to sync up with each other. So that's pretty nice. It means my, these timestamps that are in the range of tens of thousands of clock cycles are accurate to within like 4 clock cycles. So it's pretty easy to tell if something changes in the processing, because I don't have to ignore a whole lot of noise there. Now you might have seen in the output here there is a lot of unusual output that doesn't seem to mean much, and I think that's still just software bugs in my test setup. So you can see it's giving kind of a summary of what the latest guess is in each of those lines that says trying, and then a file name, and then a bunch of other counters. But then every time it says unusual result, that's something that had a clock cycle count that's outside of its normal 15 clock cycle window of what it accepts. Oh geez, Tuco, don't stand on that, please. I love you, but don't stand on the experiment. So anytime it gets a result that's outside of that window, it'll eventually get around to printing it out, and it also eventually gets around to trying it again to see if it can verify the weird result. And so that's that repeat count here. So if you see rep equals 0, that means it saw something unusual, it's trying it again once. But if you don't see it again, then that means it went away, it was just a spurious thing. So I'm getting a whole bunch of rep equals 0 results with just totally weird clock cycle values, and I'm almost entirely sure it's a software bug. I mean, it's either a software bug or hardware bug, because those are the domains we're working in. But I think it's a software bug at this point. But everything I've done so far to try to debug that on the oscilloscope to show the actual events involved, those events are really solid. So, I mean, it's acting like the software is reading the timer register while the timer is being updated, because the bus that the CPU is using to access these registers is only 8 bits wide. So even if I had like a 64-bit timer register, the CPU would be reading it in 8-bit chunks, which would introduce some synchronization hazards. So that's a problem for some of the other timers, but these timers shouldn't ever be changing while the CPU is reading them, just based on the sequence of events. So there's something still going on in the software that I don't understand, which is leading to those results. But every time one of those happens, because of this retry that I've added, it'll go ahead and run it again. And there's a variant of this experiment where I had basically a control version of this. So I may have mentioned earlier that I know that if I set the volume label flag on a directory entry, then it gives up on parsing it before it even tries to look at the file name. So I can make a control experiment then that takes some of these. I just chose like any file name that starts with the letter D. Then I had a little bit of extra code that set that volume label flag so that the result would be lower. And then that verifies that my test is working, and I can see that I start getting a whole bunch of unusual results with steadily increasing rep counters that all start with D, and then they start just coming back every time it retests them. So that's what I expect to see. The rep zeros, I could debug those more, but I've already spent a bunch of time on that, and I just want to keep this running while I work on other stuff. And at this point, I'm fairly confident that my test apparatus will find the 4-letter prefix of the file name if my hypothesis is correct, that it is matching the file name at this stage and that it's doing it so based on 32-bit words. So that's about the state that this is at. So I think, oh hey Tuco, you're under here. Meow. He's really anticipating when I throw the bolts. Like he's off 6 feet away before the bolt has even left my hand. He just really wants to be there when it lands. Okay. Well, just for some additional context, I might briefly go through some of the software that's running that test, but then I think most of what I want to do in this stream is preparing this PLC for the next experiment. So I will, oh geez, thanks MagSafe. At least this experiment can run off of battery power. Yeah, let me start the recorder so that we can get some computer footage. What is this programming doing? Okay. Hey, Tuco. Okay. Fishbowl recorder is operative. Oh, I'm catching up on chat a little bit. Hello, everyone. Oh yes, beer. Beer's a good idea. It seems to help with things like this. Hard to know. Oh geez, except when it foams over. Yeah, so that happened. All right. Oh, and there's all sorts of junk on the screen right now. Let's turn off. Oh, using the worst mouse ever. Let's turn this and this off. Duke's just sitting there. Maybe if I sneak up on him with the zoom lens, he won't run away. I'm so looking forward to having a robot that I can use to photograph Tuco. Oh yeah. Hi everybody. Hi Dr. Nick. That's a callback from recent chat activity for anybody who's there. Okay, so let me clear some of this junk away briefly. Also, there's something very sharp on the floor. Sometimes this happens. Oh. Is that glass or ceramic? I can't tell, but it was in my foot. Ooh. What is this? That's hot glue. That is not as sharp. Okay, let's so I think I was just going to briefly take a look at some source code, which I already checked into GitHub, so this is just going to be a web browser activity for the moment. Oops, that has too many letters. Alright, so this is the project that's currently running on this little desk that I keep kicking and or having my cat trip over. And yeah, if you want to read that, you can pause it, but it's also all on GitHub. Basically, I did a bunch of cleanup on this over the last couple days, and it's now much easier to write separate experiments for it. And basically, the main program here is now back to being relatively simple. So we have a bunch of initialization. We reset the target for the first time. We'll do subsequent resets either when we have a timeout. So there's like a little watchdog just to make sure we keep making progress, and if we don't, it'll reset the target. And it'll also reset it every time we reach the end of the root directory, just so that we kind of keep going as quickly as possible. Oh, man, he's such a beautiful cat. And then really just there's whatever test you want. In this case, I thought I would try combinations of 32 bits of A through Z, and then I thought it would include a wider swath of ASCII characters. So this time, include a bunch of the special characters too, but still have that same repeating pattern of 4 bytes, assuming it's doing a mem compare. So this will just run and then stop when it gets to the end. I'll get the results by logging the serial terminal output. So I'm just running the serial terminal inside of an instance of a script, the command line utility that just logs everything in your terminal. Then up here, this is all still very low level. I was spending so much of my time writing this just wishing I was using a slightly higher level language so that I could have a little bit of abstraction for some of this. But I ended up just using a pretty basic FIFO queue. And this is the style of FIFO queue where you have a circular buffer, and then you have a bunch of pointers into that buffer that can just sort of increment endlessly. But every time you actually dereference into this buffer to get a real concrete address, you do a modulo to cap the index to the size of the buffer. So that way you have, basically I wanted to not have to worry about wraparound in this for one, and I wanted to have each experiment to get a unique ID. So for that, I just ended up making the FIFO queue identifier 64-bit, but still using a relatively small buffer size of 128 entries. Is there anything interesting in here? A lot of this is just going to be C code. Yes, you might know what C code looks like. It's just a pile of functions, all alike. I don't know. I ended up having to add some more hardware peripherals to this. That might be a little more interesting to look at because the hardware is, I don't know. I find the hardware, the MySock hardware stuff a little more interesting than C code. Basically, this acts kind of like a, well, there are kind of two ways that stuff happens in the background when this runs. So like from main's point of view, it's just sitting here in a loop calling guess file name, and then from its point of view, it's just like magic. It just kind of happens. Where's the cat? Oh, there he is. But there are a few different ways in which things are happening in the background here. There are interrupts going on. So there's some interrupts that are unrelated to this project, like the UART and the timer have their own interrupts. There's also an interrupt for the SD card emulator, which actually needs to quickly either fill or empty the buffer that contains one block of data. So that interrupt handler actually needs to do a reasonably large amount of work, but I still want to keep it pretty bounded because the actual experiment is just completely halted while that's happening, and that code can't use the serial port because that would cause a deadlock as it waits for another interrupt that's blocked because of the way the priorities are set up. So because of that, that's a big part of the reason there needs to be so much asynchrony, is to kind of keep the actual block interrupt simple. So the block interrupt ends up going through the FAT file system emulation and then kind of lands here. So this FAT root dir entry gets called once per directory entry in interrupt context. So this function's job is just to, as quickly as it can, without doing anything else that's going to block because of interrupts, or block waiting on other interrupt handlers, to fill in this buffer with one FAT16 directory entry. So it's got a special case for the volume entry. Otherwise, it's just copies of the same thing. That's the control experiment I mentioned earlier. Just the simplest thing that I could do to actually test the rest of this code. But yeah, this relies a lot on special hardware peripherals. So like these functions here are auto-generated wrappers around the timers that are automatically latched anytime the transaction, anytime we finish sending the data for the transaction, or anytime we get a new read in. So yeah, that's just kind of, annoying low-level C code. I thought the hardware was more interesting. So this stuff didn't change too much. I ended up mostly just adding a new module, well, two new modules. I've got like a little clock generator. This is what it takes to just make a little clock generator that's accessible over the CPU. So I have a divider register here, which is, you can set it to 0 to turn off the clock, or a non-zero number is effectively the clock division. Well, the clock division is like this plus 1 times 2, so kind of a common clock divider formula. Oh, this was really fun. This is something that would have been super annoying in Verilog, and it was just nice to have a little bit of extra abstraction in thanks to MyGen. So here, this is another peripheral with, so this auto CSR class plus these CSRs give us kind of a really easy system for adding registers that the CPU can access. So we give ourselves just like a hidden register, first of all, that's just a free running counter, no way to reset it or anything. But then there's a CPU interface here such that there's this capture register where we don't actually store any values there. We just want the enable signal on the right so that we use the act of writing to this register as a timing reference for something. So that gives us this RE signal that just pulses when you write to that capture register. And we feed that into this positive edge function that we'll get to soon. And the output of that goes into this capture timestamp register. So then we follow that pattern a few more times, and we have these events that capture timestamps from the SD emulator. based on events that we're pulling out of the SD card link layer. So we didn't have to like run a lot of plumbing between modules here. We could just use Python attributes to pull these out. And here we're looking for the beginning of the block read activity. So we pull out the signal and look for a positive edge on it. Similarly, the beginning of the write or the beginning of the done period, which is a little bit weird, but for symmetry they use that. I mean, for crossing clock domains mostly, they use this concept where the doneness starts when the transaction is done, and then the doneness ends sometime when the next transaction is in the process of starting. So then here we can have this fairly abstract way to just kind of create this semi-anonymous signal that stores the last value of this trigger, kind of pump that in clock cycle by clock cycle, and then if we detect a positive edge, we can latch the clock. So I find that much more relaxing than the equivalent Verilog code. That's not really new. All right, I don't think there's anything interesting here to go into other than what I've already shown. Yeah. All right. Well, that experiment's running. The cat is catting. And I think it's time to do a teardown on this nice fresh PLC. Yeah, I don't see the cat. Oh, there he is. He's a stealthy little critter. I'm still trying to figure out what the sensor package on the new hovering cat camera is going to be like. But yeah, at the very least, it's going to have a camera and some kind of range finder for focusing the camera. It might also have a thermal camera for sensing the cat. Oh yeah, it looks like there was a question in chat which I haven't been good at paying attention to, and yeah, just for some context about what the emulator thing is. And yeah, the name of the project that I've given it on GitHub, if you want to just search for it, is flipsyfat, since it's flipping through file names in a FAT emulation. But the giants I'm standing on the shoulders of here basically are the MySock system on a chip, which is in turn based on the MyGen hardware description language in Python and the Lattice Mico32 or LM32 processor. And then this SD emulator is a modified version of this core that was originally written for Google Project Vault in Verilog. And then I mostly just modified it to add an SPI mode for it. There's that. But yeah, the actual system on a chip, aside from some little peripherals, is mostly just the CPU and the SD emulator core hogging most of the space. Oh yeah, US Water Rockets in chat says the cat camera needs a thermal sensor so we can have predator vision. I think that's a great idea. Yeah, I think the question at this point is just how much stuff goes on what physical objects. It's like, what should go on the moving robot? What should go on the gimbal on the moving robot? What should just go like on someplace high up in the ceiling and doesn't need to move around? So I feel like the thermal camera might want so like the one that I'm planning on moving around, I probably want a pretty smooth pan tilt and zoom, which is why I have it on like a quadcopter gimbal. But the thermal camera, I imagine I just want that to be further away. But I'll need to experiment with the field of view of this and see what works. I'm thinking the thermal camera, it might just be something I can either mount stationary or on a simple gimbal and then just like clamped up to the mezzanine up there and not even have to have it on any kind of moving robot. But yeah, let's do some hardware. Let's not stop the moving recording, thanks. Okay. So what do we need? Well, so we're doing voltage glitching. We need the voltage glitching board. This is what actually inserts the glitches. We need a way to, well, need is a strong word, but it's very helpful to have a way of seeing what you're doing, which the most effective way I found to do that is to attach a low noise amplifier to the core voltage rail of the processor and to listen to it on the oscilloscope. So we want these two things. Oh, Tuco, don't stand on that, please. Maybe I should lock the laptop, although he's kernel panicked this thing even when it's been locked before. Maybe I just have to make some room for him to sit on this. Hey, Tuke. You want up here? You just want me to throw bolts for you, honey? That's a big yes. All right. So yeah, power trace output, glitch input, also clock input, since I want this running off the external clock I'm generating. Also optional, but probably I'm going to do it just for consistency, removing the Ethernet isolation transformer. Since I don't think it's actually necessary, but I've been doing it on the other boards for consistency's sake mostly, and also because I haven't verified that the underclocking setup I'm using works with the Ethernet transformers in place. Oh, I was just trying to parse some more suggestions from chat. It looks like, oh, yeah, Kyle was saying, why they had to call it the FLIR 1, which sounds like one of those FLIR devices. I'll never know. Yeah, it's a weird name. I don't know how people name things anymore. And then US Water Rocket suggests you could use the position of the flying bot to detect or to direct the gimbal for the stationary camera. Yeah, totally. I guess there's also a wider question, which is, I mean, I'm getting a little off topic. This is kind of a question for another stream, but there's a big question of what sensors I'm going to have. There's a, I mean, it's a compelling thought to just, you know, use the Vive Lighthouse sensors to get an XYZ position for the camera bot and just solve everything with that. I don't think I can totally rely on that though. So, I mean, I think I've been, and I'm saying that for a couple of reasons. One is, my experience with Lighthouse has been pretty bad when it's in sunlight here. Like I have to be really careful to close all the blinds and everything, so I don't know if I'd be able to rely on a good signal when I'm just like randomly streaming during the day. And there might be ways around that, but you know, in general, the space here is kind of outside the scope of what the Lighthouse was designed to operate with, and I'd love to hack on it and make it operate in this space, but that itself is a project that has its own risks involved. And so I don't necessarily want to design my cat camera to rely on having really good 3D tracking throughout the entire space. Because right now when I use my Vive for virtual reality, I usually do it in the evening, and usually like it only covers like half the space here because the geometry is just weird. So yeah, I'd like to use the Vive tracking for this robot, but I think that's going to be like a second tier sensor beyond just having something that keeps it in the air and keeps it from crashing into stuff. So for that, Duke, where's your bolt? There's a lot of different stuff I could use to influence that. I think one of the constraints I've been most concerned about is keeping the camera in focus, and kind of as a side effect, keeping the bot at a relatively fixed distance away from what it's looking at. since I think that'll be a good way of keeping it stable as I command the winches to pull it one direction or another. I'll want some kind of countervailing stability. So, I'll want something like, well, keep the force on the other cables within range, but the force sensors can't be part of the really fast control loop since those are slower. But anyway, that's a diversion. Tuco, where's your bolt? Oh, it's way over there. Oh, wow. This experiment is going really fast, actually. It's up to W on that first test that just includes the A through Z letters. The times I've looked over here, I haven't noticed any high rep count results, but they do time out after they hit like 60 reps or something, so I would have to go look through the serial log to be sure nothing happened, but it's also possible that the file name includes a character that isn't just A through Z in the first four letters, which means that I'd have to let the longer test after this one run. Anyway. All right, let's get some kind of teardown-like footage of this. Mikey in chat says, we can also study what psychological effects a stalking camera has on a cat. Yeah, there's that. I mean, yeah, it's accelerated modernity for us all, I guess. All right, so we are recording. I don't think I even need the bottom board from this since I left it on my other test harness since I didn't need it for this SD experiment. So I can leave the bottom board unmodified. The only thing I took off some of the connectors just to make more room, and I also took off the battery backup for the real-time clock just because I didn't want voltage on there while I was messing around with it. And also I didn't want the real-time clock to have a backup. Oh, the case took the SD card drawer with it. Well, our old friend. So, oh yeah, I should warm up the hot glue gun. All right, so this is the normal stack for this. So also get some grounding on. All right. So you can see it's a bit of a Rube Goldberg tower in here. Like, it's kind of unwieldy to actually mash on these buttons when the case isn't in place, which is why I made my own separate button panel. So This is me debating whether to take this LCD off of here or to take the one off of the other one. I think I might take it off of here. Alright, anyway, the LCD and backlight are pretty self-contained. They just attach with this connector, and then they're glued and snapped onto the circuit board. And then this plug-in module, these pins are only for the buttons. So I don't need the button panel at all because I have my own version of that in this test harness already. What I did with the LCD on the other board, which I might just do with this one too, is I removed the LCD from this back panel and then glued it over here at a more convenient angle. So that's retained with both some sticky stuff and those clips. So I've got the clips out on this side, and then I'm sputtering away the sticky stuff. Alright, LCD extracted. Buttons, don't need these, because these are really hard to use in a prototyping scenario. So I made my own on a breadboard. Let's extract this because we want it. Yeah, I think I voided the warranty. So this, if you squeeze it a little harder than usual in some axis that is unusual, I think there's a snap that you can unsnap. Is it on this side? There we go. And then a little adapter, which is some decoupling and pull-up resistors. Alright. Don't need the backboard at all. This one is basically a power supply and I/O expander board. It's got a step down that goes from like 12 or 24 volts down to 8 volts. It's also got I think this is the I/O expander chip, but I haven't really looked at this board super closely since it hasn't been especially relevant. This does have some hardware that the microcontroller tries to talk to under normal circumstances, and if it fails, then a watchdog resets it relatively fast, like within a second or so. So I do need this to run most of my experiments, but I've got another instance of this that should be fine, so I can just put this aside. I think there are also likely just different versions of this board for different electrical environments. So there's at least a low voltage and high voltage version of this, but I can imagine them wanting, different versions for different, different regulatory markets maybe. All right, don't need this. Don't need the drawer. Let's just put these back together. I think that's all the stuff I didn't need. So the bottom and top boards will hang out together for now. These are not going to stay together. I just want them to not get lost. This seems to be almost symmetric, but alright, that is my completely good as new PLC with all of the relevant parts. Let's have a better work surface here. And on my work surface. And you can hang out elsewhere. Alright. So this board, there were a few modifications we wanted here. There's a lot of stuff I changed. I'm just remembering another one though. I should make a list. So for sure this needs clock and reset inputs. It also needs its relay outputs broken out. Since I'm using those to synchronize the voltage glitching test still. Ethernet transformer. And then the obvious ones, the glitch board and the amplifier. I also might need to do some additional power supply filtering. Well, we can save that until, because I really don't want to have to pull up the VCC pins on this one too, unless I have to. On the other board, if you notice that copper stuff on the top, that was from lifting all the power rails, or all the power pins in the processor, so that I could separate them and put them through a filter. And that was for an experiment, and I haven't determined whether or not the additional filtering that was left over after that experiment was still necessary. So I'm going to start out without it, but I might have to add it. But if I do need it, I think I can probably find a less annoying way to do it if that's my goal. Okay. So much to do. Well, you know, if I'm using the hot air tool anyway, I might just pull the whole resistor bank that connects the relays to the processor so that I can break them out individually. Because I need the hot air tool to get the clock crystal off. And if I'm getting the board hot anyway, I might as well pull some other stuff off while I'm at it. Yeah, the other board is full of hacks that aren't especially necessary right now. Yeah, let's just start pulling stuff off with hot air, because there's a few things that I need to yank at this point. Oh, Milan in chat says, I didn't know Miss Scott was a lefty. Yeah, I use my left hand for a lot of things. I write with my left hand. I usually solder with my left hand, although I can, stuff like soldering I can usually do with either. I think writing is one of the few things that I only do with my left hand. That's probably growing up as a lefty that was forced to adapt to a lot of right-handed stuff, but maybe there are other explanations. Last time I just brutally yanked off the transformer, but I'm going to try a slightly more humane approach this time. It would also be nice on this board to keep the area right around the chip footprint free so that I can swap out chips on this board if I need to. Not that I have plans to do that right now, but that seems like maybe a thing that I would want the option for. And the crazy mod that I made on the last board's vCore, or not even vCore, but VCC Rail totally precluded doing that. I guess it occurs to me that I could have turned this on, but instead I took it apart. I'm pretty sure this one has been tested. I think my coworker who sent me to this had used it before. This transformer is not nearly as easy to melt as I was expecting it to be. Tuco, what do you think about surface mount rework? You do it with bolts? What do you do about little stuff? I'm kind of glad Tuco's not into little stuff. It's really good for his health. Man, what is up with the heat on this board? Oh, there we go. It's getting started. There we go. Transformer off. Let's go for this resistor network next. Oh geez, Tuco's on the keyboard again, isn't he? Tuco. Oh geez, what are you doing? Oh, hey honey. I love you, but I don't see my terminal scrolling right now, which is a bad sign. Hey honey. Okay, it wasn't scrolling because he had started selecting something, but the experiment is still running. It's in the non-ASCII part of the everything. It's getting stuck a lot. It's also unstucking itself. Okay, I think it's fine. Hey, Tuco. Where do you want to hang out? Oh man, what do I even do with this? Hey, Tuke, you want a bolt? Okay. Yeah, Mikey says he does it because he loves you, lol. Yeah, I know. Yeah, he likes some of the same things I do, but he shows his appreciation in ways that are incompatible with the ways that I use them. Alright, well I'm all anti-static back up, and maybe I can go back to trying to pull this resistor off. That ant is still on my desk, but far away from this action, which is probably good for his health. That. Now the clock crystal. So that one I just took off will isolate this from all the relays on the other board, which will let me use them as general purpose outputs without them clicking all the time. So it's not necessarily required, but it's useful for the lab to be an okay place to hang out in when I'm running this experiment. Got a little solder skid mark on the CPU from dropping it there. All right. I think that's everything I need the hot air for. Oh. Well, everything on the front. There's a couple of capacitors I need to take off on the back with hot air. But let's find those first. I could look at what's going on that board, but it's in kind of a precarious position right now, so let's go based on the data sheet instead. Not the thing to Google for. Does this have a table of contents? Yeah, VDDC is what we're looking for. That's the core processor voltage. You know, I always find it amusing how they tell you not to connect anything to VDDC other than a capacitor. I've got a bunch of stuff connected to VDDC on this system. Oh, to each other and an external capacitor. Yeah, so this is nominally 1.2 volts. I think it usually rides a little bit higher than that, but that's what they say in the data. Yeah, so instead of just connecting this to the capacitor, I've got a board which has some capacitors, but it can also remove the capacitors and replace them with a short circuit on very short notice. So that's what this contraption is. It's a little tarnished from the copper not having a coating, but let's get that focus. Oh. It's still warm. So yeah, 12-volt power supply, input from the chip whisperer board. So this is a kind of precisely timed pulse that has our actual glitch edge that we want to inflict on our target device. And that goes through a few layers here. There's a buffer that cleans it up, and that's also combined with a high-pass filter, so that if the output gets stuck high, we don't end up burning out anybody's transistors or voltage regulators. And so this little tiny chip in the SC70 is a dual inverter with a Schmidt trigger input. So it's using the first one just to buffer the input, and then the second one plus some passives to be the high-pass filter. And then that goes over here to two of these little chips in the SOT 23.7 package, or 23.6 package. And that one, these are really fast MOSFET drivers. So they're basically little H bridges that are powered off of 12 volts and just slam the gate of this MOSFET up and down whenever they get a logic input from this chip. Basically just very, very speed optimized H bridge drivers. And then these SO8 packages are the two MOSFETs. So basically this line here is the VDD core transmission line, if you want to think about it that way. And so there's a little bit of capacitance over here that's always connected, then one FET that we can short out. We can short out that line with. Then another FET that we can connect that line to these capacitors through for kind of extra bulk capacitance. And then these capacitor groups here are power supply for the MOSFET drivers. And then it's basically this thing. We made this on an earlier stream. And then this twisted cable here is what goes right where some capacitors used to be on the circuit board. That's what I wanted. I lost my place in this PDF. Pin diagram. Okay, so there are two VDD core pins. There's this one here, which I guess I can't highlight, and another one on this side, VDD core. So we're going to try to find those. Well, I think the easiest thing to do last time was to attach to the capacitor sites on the bottom of the board. So we're going to try to do the same thing. But other options are open if something is easier on this board that isn't modified extensively already. Hey Tuco, where are you? Oh. I think he's hanging out near the hallway. He was over by the door. Tiger. Pin 1. Alright. So we've got some JTAG pins, VDD, bunch of IOs. Is that another VDD? I think that might be the pin we're looking for. If I remember right, this is why we're not getting them on the top. They connect in underneath. Oh yeah, and here we've got a good landmark, so you can easily see the place where the oscillator used to be. And then just getting momentarily distracted by whether we want OSC0 or OSC1. Might have to look that up again. Then all of that isn't really accessible. It's going under the chip. So let's grab one of these on the top temporarily with the meter. Okay, maybe it is easier to either use my JPEG or cheat off of the other circuit board that I already figured this out on. See if there's any chance I can hold a probe on that pin while I probe around. So I've got that. It's already slipped. I hear you, Tuco. Oh, that's right. This looks a little familiar. I vaguely remember them using a tiny polygon fill for this net. I think that's what we're looking for. Okay, yeah, that's the one. I'll flip this board over and show you what I'm talking about. Oh, this vise does not quite have the tallness attribute. That little polygon is our core voltage. So we want to pull off those two capacitors and attach our board right where that usually hangs out. And the one on the left, I think, is ground. Let's verify that. Yeah, that's pretty groundy. Cool. Actually, maybe I'll use 2 soldering irons to pull these off instead of the hot air tool. That might be faster. No. tip on the right needs to be wet with some solder a little bit. I'm using these for the wrong job. The one on the right is harder. I should use the nicer soldering iron for that. That's much better. Get off of there. Not quite what I was going for, but there we go. All right, turn that one off. Clean this up a little bit. Oh yeah, this would be a great job for soldering iron tweezers if I had those. I do want to kind of flux this up a little bit. So I'm going to be soldering here some more. All right. We need to get the other boards mechanically secured before we can really attach the wiring there. Oh, I need a bit more of that twisted magnet wire. Oh, that can wait until the mechanical securement. All right, so mechanical. That's where this is all going to end up. Maybe I can find Tuco's hangout and put the camera over there. Hey, Tuco. Oh, cat. All right, so on the other one, I had this board mounted kind of over here, and I did so with a combination of super glue and hot glue. Tuco wants to go outside. It was something like that. Oh no, it was on this side. That? Oh yeah. There's a little there's like 4 millimeters of overlap there that I can get to make a nice solid super glue bond, and then hot glue the rest. So I think that's the plan. Do I have a clamp? So it'll look pretty much like that. And that should leave me enough room right over here for the low noise amplifier that I can add on. There's actually already, like, this kind of clicks into place where I made myself a little mold from the previous super glued joint. Oh, I need another clamp. Is it still running? Seems to be running. All right. Chica. I think he wants more food. Kind of late for that, though. Okay, I think these clamps plus some super glue plus some hot glue will do the job. This is basically the same approach I used last time. A little bit of that seeping into the joint should do it. And then a couple of dots on that side. Take off the clamps in a sec and add maybe more hot glue to this. Also in the hot glue department are going to be, well, the LCD is probably the major hot glue item. So normally that goes in, oh, let's get a better camera angle. Emergency wrench again. Oh, this camera arm is really nice when it works and really annoying when it doesn't. That's solidly in the not working department. The ball bearings are not anywhere near where they should be. Man, if people really like this, I could have another stream that's just all me fussing with my magic arm. It'd be great. That's better. That was worth it. Oh yeah, servo-powered camera arm is the next project Mikey suggests in chat. That would be fun. That would be servo AF. So this thing, I think we can go ahead and add a little more hot glue in place of one of these clamps. I hear you, cat. All right. Well, the LCD. For that, I was basically bending this over and gluing it to this capacitor. And let's put this in here. Oops, that's warm. This in here as a guide for how much space we have. So this is a very delicate cable. How did I even do this before? Like that. Yeah, so keeping this still is good for it. Bending it this much, not so much. But this will keep it out of the way, otherwise it'll be sitting right on top of the CPU. that's what we got so far. So we can take this clamp off now. And a little more glue. Before we attach this amplifier, let's take the SMA off of the input because we want to add some resistors and twisted pair there instead. I mean, I guess I could use coax for that, but I think I'm going to use the same strategy I did last time, which seemed to work out pretty well, which was to mount this physically close, but then instead of running like 50 ohm coax here, to basically bring a low impedance twisted pair up here and then have some resistors. Well, I'm pointing to the wrong side of this, but have some resistors up here to act as impedance matching so that this amplifier sees a 50 ohm input at least. I don't know if it's a great solution, but it seems to be working really well so far, so I'm going to stick with it. Oh, it looks like some folks in chat are saying the audio is out of sync. I suspect that's on the transcoding side, but it might be OBS. Let me see if I can do the thing where I really quickly stop and then restart the stream, and Google and all of them don't actually notice. It'll mean that I end up with multiple archive files for this stream, but it's probably fine. Alright, and we should be back. I hope the audio is better now. Yeah. I don't think that problem was on any of my equipment other than perhaps Open Broadcaster, which has been known to do the time code slip sometimes, but usually it doesn't do that if I'm sure to restart it right before I broadcast, which I'm pretty sure I did this time, so I don't know. Oh, great. Folks in chat are saying that it looks good, so thank you. Thanks for the notification and for checking in. So, all right. This is covered in glue threads. So let's pull off this SMA using a nice big soldering iron. I might end up needing other tools for this, but I think the SMAs tend to just like the heat spreads so much that I think this interconnection might end up getting hot enough if I heat up the whole thing enough from the outside. Maybe I should get out the 2 soldering irons for this too. Oh, there we go. Yeah. I remembered it being pretty easy last time I had to do this. Alright, so now, I think my strategy here was twisted heavy gauge magnet wire, and then 100 ohms to ground, 100 ohms to VDDC, and then this amplifier will see about 50 ohms there. I have the resistors handy. I don't have the magnet wire handy, so I will need to grab that. Already twisted from a previous experiment. And I didn't have 100 ohm resistors for some reason, but I think I'm going to put some 50 ohm resistors in series. I want to put some Kapton tape down. How did I do this last time? Because I remember using multiple resistors last time, but I sure thought that I had them in parallel for some reason. Maybe I'll do this with the microscope instead of the DSLR. Oh yeah, some lamenting in chat about the situation with streaming software. I haven't tried any of the commercial streaming programs. I like a lot of things about OBS, but I certainly don't like the bugs. Oh, little resistor. Let's replace this resistor. Yeah, I know some people use XSplit. I haven't tried that one yet. I just can't get over how it's a commercial program for Windows that really sounds like it should be an open source X11 app. And I've used both the Windows and Mac versions of OBS. They seem to have their own quirks, but in general the Windows version seems a lot better. That's affected the hardware that I end up having to run things on too. I flux that? I think I just am not giving myself the right angles to make any of this easy. Okay. This is huge. This tiny piece of capstone tape's enormous. Oh. I haven't looked at chat enough recently to get the full context, but it looks like folks are talking about the OBS API as being kind of not great, and that's unfortunate, because I was hoping to use the OBS APIs for my cat camera thing. I figured it might be nice to have OBS actually, you know, being the program that's connected to the video capture device, and then streaming it, but then I could have like a filter plugin that sits there on the video stream and does my cat face recognition or whatever else I want to do, or optical flow, or anything I want to do on the image other than broadcast it. It's still too big, and now it has a resistor stuck to it that I kind of wanted. Okay, I think that might be just the right size piece of Kapton. That might be just the right size enough. I guess when it comes to the cat camera, I'm imagining various levels of control. Like, you know, I'm imagining you might want one tier of feedback loops that can run in each individual motor controller without having to make a round trip back to the Raspberry Pi. And then kind of another tier of control that could execute locally on the Raspberry Pi Plus motor drivers, wouldn't need any external like base stations or applications running or anything. And that's what I've been thinking about next, since that's kind of the first usable state that it gets into. and then I would build other things on top of that. And so for that, I've been thinking that it probably just wants to have some way of basically balancing the combination of speeds and forces on the chords, not necessarily doing much else. That's why I was thinking about what sensors it would use to just kind of keep itself stable in that level of the control loop. And I think some kind of rangefinder would be nice, and I have these LiDAR sensors that seems like a really good application for them. Oh, that's a great idea. In chat, Tim suggests to put a system of levers on the floor and train Tuco to press them and let him control his own cam. I think that would work if Tuco had any motivation to control the camera. Like, I mean, you'd either need to find some other task that Tuco could perform that has the side effect of moving the camera around, or you would need him to actually be interested in moving the camera. Those both seem pretty tricky, but perhaps quite worthwhile tasks. I guess I should be running the microscope recorder too. Kyle suggests an easier solution. Find something so irresistible that Tuco won't leave it alone, and then stick it under a fixed camera. I don't know if such an object exists. I mean, the problem is the objects that Tuco finds most interesting don't stay still. That seems like an intrinsic property. Oh, and then Tim suggests put a heater in front of the camera. That's kind of what I was doing. I mean, you know, it hasn't worked as well lately because it's been warming up, but there have been a bunch of streams where Tuco hangs out on that chair next to my desk. And that's because this desk is next to the heater. It was one of those moments where I noticed what Tuco was doing, and then I used that as an opportunity to simultaneously improve things for both of us. All right, this will probably work. I need some mechanical love. Let's first cut off this extra bit of Kapton so it doesn't end up acting as a sail to kind of carry away all the rest of the Kapton. All right, maybe let's get some larger scale. So these are starting to bond pretty nicely. And here I want... The way I did this last time was I made a little metal bracket. No, bracket. I bent a piece of wire and soldered the board together with it. Do I still have that bent piece of wire? Maybe not. Maybe while the hot glue gun is still warm, I will add a little strain relief to this. So this VCC is going to want 12 volts, which we can get from the glitch adapter. On the opposite side, just so we can be aware of what we're potentially shorting out on, most of this side of the board is ground except for right around that VCC input. Trim this a little bit just so it's less unwieldy. Probably need to trim a bit more eventually. I could also mount it like that. I mean, if I knew I was using this amplifier, I could have designed a footprint for it on this board, but I didn't. Also mount it this direction around. I still got some good grounding opportunities over here, either if I scrape off some solder mask or if I just use these holes. In fact, doing something like this where I solder it to there, just edge to edge, and then run one wire over that way might actually be nice. Then I can still see the circuitry on the other side, and this wire has a pretty short path to take. Oh yeah, Tim in chat says, I like using copper clad structurally. I do too. It's a satisfying material. So yeah, I think for this, well, since I don't really need this to be removable like that hot glue joint, well, the hot glue and super glue joint I made, I might just butt this up against the bottom of the board and solder it to the copper. Thinking about where to overlap it. I could overlap it like that. I could also overlap it. Oh, I guess I couldn't that way because that has a bunch of traces there. I'm going to clean this a little bit. I made a little bit of a mess for myself over here by keeping the area, or not keeping the area around the whole flat. Let's trim my insulation. There we go. Now that hole is exposed again. maybe I tack this down. All right. So for this hole pretty nicely coated with solder. And that's pretty much where it sits. There's a little bit of hot glue holding it right now, which I just warmed up with that soldering operation. Really, I want that to clamp, I think. Oh, except that's not actually holding. That's just the clamp grabbing onto the SMA connector. Yeah, I don't really know how to clamp this. I might just have to hold it while I solder it. I think those are at least tack soldered together. Let's do the other side. Get plenty of solder in between those two things. Cool. Reflow the other side a little bit after this one cools enough to hold it. All right. Let's just make sure we have good ground resistance, but I'm pretty sure we will. Yeah, just 0.2 ohms over a short circuit. So I think that'll be at least good enough for structure and power, and then this cable will carry our high frequency signal a very short distance. All right, so this still wants power. All right, a lot of this, I'm gonna need to add a header onto this for some of the extra IOs, just like I did with the other board. Well, I'm starting to run out of steam for this tonight, which is not surprising given how late I started, but let's at least run the power wire for this amplifier. There's some other stuff I could do, like running the input wire for the amp, doing some more gluing for, well, maybe that's the thing I should do before wrapping up the stream, is solder this wire on and then glue on a header, which I can then populate with some stuff next time I work on this, which is probably in the morning. I've now made this board very hard to grab onto, which I knew that part of this project was coming, but it's especially hard to grab from the underside. Or, you know, such that you can work on the underside, which I guess would be grabbing it from the top. Okay, maybe I don't clamp it, maybe I just set it on the table. So this is really just a matter of going from the easiest place to get 12 volts is just going to be the tip of this DC jack. Use some 30 gauge wire for that. Oh, Tuco's in a great spot for camera. Where is the camera? He's on the soft thing, which is pretty nearby, but I still have to walk over there to adjust the camera. Mikey in chat says, surely you're overdue a holiday. Well, I don't really know how to take breaks. I mean, I've done, I think I just have a long context switch time. You know, I've had years in the past when I did a bunch of traveling, but that's not often what I'm in the mood for. At least right now, I really like just digging into a project and feeling like I can get something done. Did I really put away my wire stripper? And traveling, I mean, I think traveling changes so much depending on what the context was. In the past, when I've enjoyed doing it a lot, it's been, you know, when I did it with somebody that I really enjoyed traveling with. I've traveled some by myself, but not as much, and haven't enjoyed it as much. And then, I mean, that was also before I adopted Tuco. It's easy to just get homesick for him when I leave him alone for a while. I mean, it doesn't take long at all. I really miss that cat pretty easily. Alright, we can start out with just a 12 volt power connection on this side. This is like one of those sizes that's kind of small on the DSLR and enormous on the microscope. Are you going to help me out, surface tension? There we go. Cool. That's one side. lumpy old thing is where this wire goes. Blurp. Yeah, this circuit board blank material, well, I think it's a combination of the flux bubbling plus not having plated through holes to give the solder something to really hold on to tightly. And I'm just going to tack this down a bit so that it stays near the ground plane. Like that. Alright, so amplifier has power, glitch adapter's connected. I still need to attach both of them to the actual business end where the V-core goes, but I'm going to do that when I'm a little more fresh to solder tiny things and not get frustrated at them. So, not going to do a whole lot more on this tonight, but let's at least glue some headers onto here. So last time I did this, I put the headers all along this top side, which still seems like a pretty good idea. So let's get some headers ready for that and mix up some epoxy. Oh yeah, that's very relatable. Kyle in chat says, I like traveling but also hate it. Nothing worse than sitting in a hotel room reading a data sheet and feeling that niggling guilt that you should be out doing something. But after a while it can easily get to the point where it's all a bit much and I need to sit around and do something sane. Yeah, all those feels. I really have a hard time getting a good balance between those. One of my favorite little brain weasels is when I'm doing something that I've, intentionally gone out of my way to plan. Like, I guess this happens a lot when I'm, spending time with a friend or when I'm going to a concert or something like that. And I just can't stop the brain from churning, and I just, usually if I'm out seeing a show, about 30 minutes into the set, it's like, oh man, I've just got to go hang out in CAD and work on this. And so now I'm multitasking, trying to enjoy the rest of the set while also kind of really wishing I'm home working on the project. It's a strange thing for brains to do. Epoxy and headers. Oh, what kind of headers do we want to use? I thought about using dual row to have more room, but the single row is probably sufficient and it's a little easier to work with. Let's just shove as much single row header onto this as will fit. So I think basically that, and I can start out by soldering onto some of these pads. I don't know if these are, I think some of these are ground. I'm trying to remember how this footprint works, because this is a connector that isn't actually populated in this plastic enclosure, but I don't know, this seems to indicate that some other version of the enclosure for this device also has an input port in addition to sort of an output port for daisy-chained devices. So, there's no mention of this in the documentation that I found or in the software, but it's connected to, I mean, this is partly how I figured out how their port's pinout was likely wired. It's by following the unpopulated traces from this to the CPU. But one side of it actually goes to the pins, the other side of it is no connect. I think the side toward the edge is going to have pins, and I think we're going to end up with some ground and some stuff we can use, so that'll be fine. I'll just want to make sure that I don't short anything out, but I can use those as a combination, maybe useful electrical thing in the future, and definitely useful mechanical thing now. And how much of that can we fit? The pitch on that is a little unfortunate, because I can't actually get all of these to... I mean, I have to skip a pin, which is a little annoying, but it's fine for mechanical reasons. It's just, if I do end up using this electrically, then that could end up being frustrating later on. So basically, you know, I want this such that over here, especially, I have room to attach things, but it isn't going to short out anything that's already there on the board. That's JTAG, which could be useful in the future. I designed a little flex cable breakout for that, which is attached to the other board that I might move or make another one of. I think that's kind of where we want to tack this down. Is there enough solder on this to actually work? It's just the tackiest of tacks. Okay, let's tack that in a slightly less tacky way, and then do the epoxy. Alright, there's my mostly mechanical joint at the moment. It may have electrical utility in the future. And over here it's just kind of hanging out. Let's mix up some more of this 5-minute epoxy. And my goal with the epoxy is going to be to get it such that it's supporting it structurally, but not covering up all the area that I'm going to be wanting to solder to. So probably here, just like a little bead of epoxy between the tip of this and the board, leaving an area kind of further up on the stem of each header to solder to. It's always a balance between how much pain I want in different parts of this process. Oh yeah, And then also in chat, let's see, yeah, so Kyle says it's just harder to turn off the tech brain once it gets going. And then talking about using beer to turn it off, but the beer just tends to be technical fuel, and yeah. I was thinking about that too, like I don't know, it's like I think maybe when I'd like just discovered beer, or like just discovered weed, it was something that was like novel and relaxing, and then it just turns into something that can just become tech fuel along with anything else. Like I feel like the brain, or at least my brain, just tends to figure out how to convert anything it can into technical output, no matter what it is. I guess it could be other kinds of output, like creative output, but lately it's been technical output mostly. Man, this epoxy smells bad. Let's get this on there before it all solidifies. This corner is where I needed most of the glue, since that's where I don't have a solder anchor. On the other board, I soldered some of these to those Ethernet LEDs, but that turned out to not really be useful, and so I'm going to keep the LEDs this time. The LEDs are actually pretty accurate with regard to timing, but they're accurate relative to the packets themselves, not when I'm processing the packets, which is what I ended up actually caring about. It's not the end of the world either. If I get some of this on a signaling need, it's not that hard to dig through, but it's just an extra annoyance. I think that'll do it. Oh, Tim says you need some fiberglass tape under that header. That's interesting. I don't know about fiberglass tape. I've never used that for prototyping. Or is this like an epoxy reinforcement thing? So the JTAG is still pretty free. Real-time clock is a little gooped, but I don't really care. I mean, I guess I slightly care, but only slightly. Let's try to keep this off the JTAG. Epoxy's going to start setting up very rapidly any second. And I should stop fussing with it, really. Oh, I see. Yeah, Tim says even just putting something porous under there like paper would help. Yeah, that's a good point. If I wanted it to stick a lot better. I mean, I think so far in my experience, this combination of the circuit board and epoxy already sticks way well enough for this particular kind of application. But yeah, if I was going to be epoxying something on it, that would be under a lot of strain. Like I'll think more about roughing up the surface next time I am epoxying on an SMA connector. Usually with the SMA connectors, though, I try to have them soldered onto a nice big ground, so that helps out with mechanical. I think this is enough fussing with the epoxy for now. This isn't perfect, but it'll be enough for a starting point. Oops, I got a little epoxy on my glass surface. Oh well. Slightly tempted to clean up this side a little bit. Ooh, gooey. Alright. So maybe just clean off a couple of these that I don't think I'll be able to really access otherwise. Okay, that'll make my job easier later if I do need to get in there. But I'm not going to worry too much about it right now. I think that's what we're left with. Yeah, there isn't a lot of structural support necessary. I mean, this is way overkill for what's actually necessary. In fact, I'm going to try to set this like this so at least it doesn't drip toward the board any more than it already is. Because that's enough support for the header for sure. And yeah, I mean, I'm usually pretty gentle when I assemble stuff in this apparatus. So look what we've done. We've taken an off-the-shelf PLC and voided its warranty and glued a bunch of stuff to it. It's totally useful. Well, this is a big step along the way to getting it back on our voltage glitching horse, so that'll be happening real soon. Until then, I should finish my beer and maybe get some sleep eventually, and do some more scheming about this cat camera. Next time I do a stream on the cat camera, I think I'm going to be testing these. So I got some of these LiDAR rangefinders a while ago. I think it was either when they were in Kickstarter or shortly after. It's the LiDAR Lite. So I want to see if I can use one of those as the focus rangefinder, and possibly another one of those as kind of a vertical stabilization / obstacle avoidance rangefinder that's just pointed straight down. So I think maybe that involves seeing if I can attach the rangefinder onto the side of the camera on the gimbal without it being too heavy, and then if there's some way I can get the signal back, either through yet another wire in the gimbal or through IR perhaps, since it's not something I need a lot of bandwidth for. But oh, good question from Ryan about the cat cam. How do I plan to get power and data to the cam along one of the links of paracord? That's a good question. I'm still not entirely sure. Basically, I have a plan for, a cord bundle that needs to get from it somehow, or get to it somehow. And the cord bundle has SDI coax, 12 volts DC, and one Cat5 that will probably contain 2 separate Ethernet networks for the shop network and the motor controllers. So it's not a lot of wiring, but it will be some, and I need to keep it out of the way. So I've been kind of envisioning something where it's not complicated, it's just like I statically like I need another ceiling anchor for this, and then I use like elastic cord in several sections to bring down loops of the cable, so that basically I want to balance it so that it's pulling up with a little more than the weight of the cable, so that as this bot is moving around, then it can kind of pull the cable down as it needs it. So that's my idea so far. It's certainly possible that I'll need something else motorized just to move the cable around, in which case I could have a 5th winch bot for that, maybe even something with a lower spec motor. But I'm hoping I can make that passive. It also doesn't seem feasible to move that along the cord, since that would eventually involve putting the video over a slip ring, which I don't think I want to do. I don't think that would be good for noise. I can't imagine, because like if I have this rotating spool that's taking up the cable, then somehow it has to get out through the middle, which I could do with a slip ring, which might do for power, might even do for Ethernet, since I can resend stuff, but for video, I imagine that's going to lead to a lot of dropped pixels. Well, and Mikey suggests 12 volts over the cables, and then Wi-Fi out, but I don't want to use Wi-Fi for this. Like that's a big reason why I'm not using the GoPro camera. I just can't get reliable Wi-Fi around here enough to do high bitrate, low latency video. So I'd really like the video to be wired or over something that can handle dropout a little more gracefully. Oh, an interesting suggestion for Tim, or from Tim, is that I can take the video up along the rotating spool, but then instead of using a slip ring, just use RF to send the video over close contact, which that might work, but I mean, there's just a signal integrity problem there. Like, you know, this is HD SDI, so anything I do needs to be able to pass a 1.25 gigabit signal without significant droppage. And then another crazy idea for reducing the number of wires using optical fiber. Well, yeah, I could throw some expensive hardware in this to give me fewer wires, but right now it's kind of a balance between, you know, what's easy to get the signals I want routed over and what's going to give me the performance I want. And so, you know, really video kind of has to be SDI. I don't really see another way to do the video. Anything networked isn't really going to be as fast as I want if I'm using this for positioning. And Wi-Fi is going to be especially bad. So definitely SDI for video. I mean, HDMI is another option, but HDMI is harder than SDI, so why would I pick that? So then, and then there's network for control, which, you know, obviously that could also go over Wi-Fi, but there's the same reliability problems. And especially if I'm using that for motor control, I want that to go over something wired and separated. So the motor controllers, I definitely want that to be wired either Ethernet or RS-485. Oh yeah, Station 240 in chat mentions that VCRs have a close-fit rotating planar transformer. And yeah, that's probably a thing, but that would need to be, that probably handles, you know, maybe tens of megahertz. This needs to handle over a gigahertz. And there are transceivers that exist to convert SDI to fiber, as Robert suggests. They're just expensive. They're really expensive. They would easily be more than the cost of the entire rest of the project put together. So yeah, a lot of it is just the kind of high-end security camera stuff that I'm tapping into for the video seems to be the sweet spot for getting long distance for cheap. So, and yeah, also Ryan points out that the looped cords with some stretchy bit is how a lot of industrial applications do it too. And yeah, that's probably where I stole the idea from. I'm sure I've seen some stuff like that. You know, what I'm probably thinking of is I used to help out in this warehouse that had a bridge crane, and its controller was on like a wire that you could pull down. And I think it was basically an arrangement of some stretchy bits and some not stretchy bits that would let the wire vary in length. So that's, I think, basically what I'm going for. And I don't think that's going to be too hard. I think I basically just need to figure out what the range of lengths of wire I need to deal with are, then how heavy the combination of all the wire and the robot is going to be together, then, find some... I'd like to use just standard bungee cables or bungee cords, since I've got a bunch of those around here and they're really cheap, but probably just getting some combination of bungee material and angles that get the forces to balance out just right. Oh, Robert has a link to an $80 SDI SFP, which I don't know what that acronym is, but based on context, I'm assuming this is, well, since we're talking about chat anyway, let me just get that on the big screen. So that would be here. Oh, interesting. Pathological patterns transceiver. That sounds like a lot of what I do in this shop. So just this module is $80, and I mean, I assume they've designed this to plug into something big that I may or may not need. Oh, I guess Pathological Patterns is the name of their product. Interesting, I might have to look into this. Yeah, also I'm not quite sure what this is in reference to, but I think if you're talking about the strategy with the bungees and stuff, I think we're on a similar page. I guess I was thinking about doing something kind of like, if I can use a pencil. Oops. I'll be breaking that. Okay, so let's make this kind of two-dimensional. So we've got a pulley over here, a pulley over here. This is our winch bot with the camera gimbal. And it'll just have some cords, and then I'm imagining the little bots will have some kind of shape that allows you to anchor them either on the side or the bottom, depending on where you're placing them. This cord would end up kind of going into the top and through some sensors and then onto the actual winch platform, or a winch roller. So it'd be kind of like that. And then I imagine that somewhere else on the ceiling, wherever we could attach it, that might be difficult, but somewhere there would be a hanging point where we would run the other wire. So let's say there's a hanging point over here too. And so then there's a cable bundle going from there to there, potentially under some tension, and then dropping down. Then also from here, there would be maybe a series of bungees looped together that I drew that not straight, but basically this would be a straight line from the top to some point on the robot, but under a little bit of tension So these would stretch out as it moves down, but just barely enough tension. And then up here, you would then have loops that kind of extend down like that. And then at some point, it would start following the cable more tightly and then down to the robot. So something like that. So there's a bunch of parameters to figure out, like, exactly what shape all of that should be for it to work out. But that's basically what I'm thinking of. Oh, interesting. Robert explains the pathological pattern, that it means that SDI's scrambler algorithm is bad and can produce a string of 19 continuous ones or zeros. That sounds bad. And then Mikey in chat is saying that I really should do an onboard winch system. I think not. Because I need the data, like the cables need to exist regardless of where the motors are. And putting the winches on the robot makes everything way heavier. So that's a bad idea. I'm not doing that. Because I'm not putting the video over wireless. That's just not something that works. So I have to have a cable. I have to have power. So, I think so far this is the only feasible solution that I've seen for getting data and power onto my bot. Anyway, I think it's time to wrap up this stream. It was a nice little off-topic diversion, but I'll have some kind of actual stream about that later on the scanlime YouTubes. Yeah, it looks like this experiment is still chugging away. Let's see how it's going. It is testing some bizarre file names. Focus. So, yeah, that text in between the brackets is the file name it's trying. So it's onto some weird stuff. No recent hits, but there might be some hits in the scroll back that I'd have to go grep for. It's going pretty fast though. You can see that's the number of times the device is reset. So it's reset 3,176 times, and that's decimal for some reason. And then this is the number of blocks that have been read in hex. So you can see that's going up quite a bit. Almost up to 1 million total experiments just since I started running it this evening. So that'll run a little while longer still. It's got some good blinking lights. All right. And the cat, oh man, he's doing so well. So beautiful. Oh yeah, Ryan also suggests that I can make the cable kind of a bigger snake and let it go over a separate pulley on the side with like a counterweight to keep it pulled. That would be nice too, yeah. I might have to keep that solution in my back pocket if the bungee thing doesn't look appealing after I investigate it in more detail. What a cat. probably too quiet to hear, but maybe you can try and pray. The experimental audio portion of this stream. Alright, I guess the cat's getting up. Time to wrap this one up. Oh yeah, Ryan says he needs a collar mic. I have tried that. I've followed him around with a lavalier mic on a couple of occasions to get samples, but it's not something I've been able to come up with like a sustainable thing to just like let him run around with. All right. Oh, Mikey says not quite loud enough. Oh well. Yeah. I think I have the gain on that mic set for me talking into it, whereas Tuco is a little more subtle with his vocalizations when he's just happily purring like that. All right, thanks for tuning in. More on this soon, and perhaps it won't be 11:30 next time. Happy hacking, everyone.